Hi there, my name is Martin Callison. I'm going to give you a quick run through of what I've been doing with the Sagitta Designer, just to give you an idea of what it is meant to do and what you can apply it to. So let's start out by creating a new project. I'm going to use TinyCLR. This is intended to eventually work with .NET Micro Frameworks and TinyCLR and Nano. So let's go ahead and do a TinyCLR application. And there's my basic application. But to this application, I want to add a new item. I'm going to add a Sagitta Design. We're just going to call it, let's call it Weather. Weather Station. Add that. I'll come back to this window in a little bit. Let's get rid of that. And let's open up the Weather Station collection here. So we have a design. Inside that design is a C# file, a breadboard, a PCB, and a schematic. Normally you might start with the schematic and then build a breadboard to match that schematic, or you might start with a breadboard and then record it as a schematic and then move to a PCB. There's no real requirement what order you do this in, but let's open the breadboarding. Here's the breadboarding, and like all good projects, I'm going to start with a breadboard. Move that over here, and then let's put on a BeagleBone Black. Intention is that the software generation will work with multiple platforms, including Linux, Mono, and so forth. It really doesn't care. As long as there's templates and NuGet packages, it doesn't care. And then it's going to be a weather station, so let's look at some temperature devices. These are all devices from Adafruit. Let's try want something that there is I²C, so we'll try this thing. When I place these things, if they're not the way I want, I can rotate them. So select one of these and rotate that. I can orient it in whatever way I wish, place it where I want. If I put something on there that I don't want, of course, I can delete it. I want to delete it off the toolbox. Let's delete it off the screen. And then, we should have a display. We've got some outputs. So let's use a Sharp memory display. Put that there. Now, normally what I would start doing is some wiring. I can't do that just yet. There's quite a bit of non-visual heavy lifting that I have to do inside the program to make the wiring work. The idea is when you drag these things on here, they're going to bring in drivers and other components from NuGet, and they're going to set up this weatherstation.cs generated code. This is not code you would edit, but this is generated by the visual tools. It will populate that with the necessary code to initialize the drivers and start a runtime. Your program, of course, you can still do in program.cs. I can also open up the main design here. And this main design will show you a thumbnail of your schematic, breadboard, and PCB designs, along with a number of properties, the drivers that have been installed, middleware that you can elect to install. Middleware might be something like a, let's say, a HTTP client or server component, something, maybe a network time protocol middleware, maybe some middleware for talking to Azure. The agents are pre-configured program blocks that allow you to do sense, decide, and act type actions. I'll explain that in a separate video, but basically it's a way of building a program without having to write all of the complex asynchronous code for sense, decide, and act. Bill of materials, all the pieces that you've dragged on, a net list, which is used for analyzing your circuit and for exporting a number of other things. And then a set of design rules. And the design rules would be a list of errors such as you dropped a component on the schematic, but you haven't placed it on on the breadboard or PCB or vice versa, or you have violated some other design rule that would make this not a running design. So, and now I could compile, and which I won't do because it hasn't pulled in the NuGet packages. That part is not fully working yet. I could compile, and I should have a running tiny CLR program that is based on the hardware design. So I can go directly from a hardware design into programming and produce this all together. I can use the breadboard design to help me cross-check my actual wiring. And I should eventually, as this system develops, be able to produce PCBs for manufacture right out of this program. Look forward to showing you more as this evolves. This is very early days. We'll try and keep you up to date. Thanks for your attention.